was here a year ago to talk about what we were doing in the area of automation to reduce costs, to simplify our designs, to reduce customization, and to improve the project execution on our projects. And so my group in the development company has responsibility both for the automation and the electrical. So I set a challenge to the electrical folks that they had to deliver something similar to what the automation guys did. And so what I'll cover in this presentation are some of the ideas that they've come up with to achieve some of the same objectives in electrical that we were doing with automation. So this chart is similar to one I showed last year, and it just points out that in our project executions, we have a numerous number of dependencies in progressing our work. We don't own I/O. They're owned by the process engineers. They're owned by the loss prevention, the machinery engineers. We don't even own the electrical loads. They're owned by the mechanical engineers on the project. So we have a lot of dependencies on others. And then we get design inputs throughout the project execution. So it'd be nice if we got it all at once, and then we could design the system based on that information, but that's never the way it happens. We'll get piecemeal information throughout the execution. And then we end up with a highly engineered, very customized solution because of the way that the information is provided to us. Plus, we've had global practices that we've developed over 30 years that result in a very customized solution. And then vendor data is always late. We order the products late from the vendors at the very last minute. The EPCs would like to wait until the very last minute to spend any money. And they really tie the placement of order to when it's going to be delivered on site, which is one criteria. The other one is vendor data. So invariably, vendor data is late. And then what complicates that for mega projects is that we have equipment being supplied from around the globe. It's not just from the U.S., it's from all over. We have multiple EPCs on most projects that have the same systems, and we will want to make them similar. And then in order to compress schedules, we got parallel design activities. So the I&C and electrical guys have to progress their design before they've gotten much input from the rest of the other disciplines. And all that results in is a lot of rework. And so what we were seeing on our projects is constant rework. During the design, it was piecemeal to us, and so we were continuously making changes. We then picked a freeze date and the design freeze, and that doesn't mean the design is frozen. That just means we picked a slice in time to fabricate equipment. The design continues on, and what happens is we'll fabricate the equipment, we'll go through an FAT, and then we'll deliver it to site, and then we'll make all the modifications to accommodate all the design changes that have occurred since the design freeze. And so what we've concluded is we've got to take a different approach. And this chart here actually shows it for electrical, where there's a number of sequential activities that have to take place. So, there's layouts or one lines, there's cable schedules. And then what happens is invariably some late in the design, there's a change from the process guys or loss prevention guys, and we got to go all the way back and redo the cable schedules or layout drawings. And what we're seeing is we're doing this constantly. And so this is what we showed last year to address the automation. First thing we did was to implement smart I/O or universal I/O or electronic marshaling or intelligent marshaling. There's a number of names for it. But the whole idea is that we could get rid of the marshalling cabinets. No longer did we have to land I/O in a particular grouping within the control and safety system. We could do it however we wanted to because it was universal I/O. We then moved that I/O to the field such that we could get rid of all of the home run cables that existed from the field to the field junction box. So now it's just a data highway. So that eliminated a lot of copper cable. Then the next thing we did was to make all of these cabinets standard. So the way we had done it historically is every one of the cabinets, we could order literally hundreds of these cabinets, and every one of them is different. Not a single one of them is the same. But what we decided to do on this approach is that these junction boxes are identical. We mass produce them, we deliver them to site, and there is no customization that takes place. So that significantly reduces the engineering. So what this results in is we've got standard smart junction boxes that we can order with an approximate I/O count. If the I/O count changes, we just order another junction box. We eliminated 60 to 70% of all of the cabinets and junction boxes. We can accommodate additional I/O by just adding junction boxes. We can order these from the factory whenever it's appropriate. So we can order them early if we choose to, or we can order them late. One thought is we order them as late as possible. We don't want to delay construction, so we want to get them in time for construction, but we would like to order them and get the last version of the hardware, the last version of the software. So that's kind of the approach that we're taking. We'll never delay construction. That'll never be an issue, but we'll order the equipment such that we get the very latest stuff. And then the status is that we've got commercialized solutions for much of this, and for all of our new projects, we're going to be doing it this way. And the only way we'll do it the old way is by exception. So somebody will have to get it approved that we'll do it the old way. So what we wanted to do was to do something similar in the electrical side. So historically, the way that we've executed projects, we've had the I&C guys that were doing their thing. We had the electrical guys doing their thing. If the electrical guys need some kind of dedicated system like load shedding, then they would put in a system. It would be provided with the switchgear. And so it worked. No issue. But it's a lot of what we think now is unnecessary equipment. At one time, it was necessary just because of speed of response. The load shedding system had to respond in 200 milliseconds or less, and we couldn't get that from the DCS. But that's changed. Today we can get that. And so what we're doing today is this. We've eliminated all that equipment. It's now, the functionality is now housed in the process control and the safety system, and no longer do we have these dedicated, diverse systems in our electrical equipment. So this is one area where we've simplified the architecture, simplified the delivery for the electrical system. We're standardizing on interfaces. We're reducing engineering. We're reducing construction and commissioning because there are less components. There's less installation and termination work. There's reduced opportunity for errors because there's less construction work. And so anyway, that's what we're doing for that kind of functionality. We then looked at low voltage MCCs, and the way we were doing it is all of the control for our motor control centers were hardwired. So all the HOA stations, stop-start stations, were hardwired from the field packages in the field to the MCC cabinet. So every time we were making a change, we were having to change that design. And so we've decided to take advantage of the smart I/O idea and eliminate much of the hard wiring. So the plan today is to use smart I/O, perhaps put it in a section of the low voltage MCC lineup, have that all hardwired to the various buckets by the low voltage MCC supplier. And then we'll deliver it to site, and basically what we hook up is the power wiring, which we can't eliminate, and then a couple of pairs of redundant fiber, and that's it. So no longer will we have all that hard wiring that we've historically included in our designs. We also wanted to look at every aspect of the way that we're doing jobs. So another area where we spend a lot of time is on specifying, selecting, procuring equipment for our projects. We spend literally months and months doing this. We spend a couple of months creating the specs. We then go out for bids, and we'll take 4 months doing that process. And while this is going on, we're having to progress a generic design because we don't know whose equipment that we're going to be using. And so we're doing what we now think is unnecessary engineering. So what we want to do is to establish common specifications with our key suppliers. So we're in the process of doing that right now. These will be specifications that we'll use on every project, and all that the project team will need to create are data sheets. So if it's a low voltage MCC, we'll need to identify the number of size 1 starters, size 2 starters, and those kinds of things in each of the lineups. But the rest of the specs will be covered in the standard specifications that we've already agreed to with that supplier. In fact, we're creating specs with each supplier. So it's not a generic set of common specs. It's very tailored to each supplier. That way we can get the amount of specs down to the bare minimum. No longer do we have to include things to cover the range of suppliers that it could cover. It's written specifically for that supplier. And so our plan is to pre-select, to get away from the need to do competitive bids. So we won't create specs. We'll pre-select. We're negotiating pricing so that we're comfortable with the pricing that we'll get. And then what we think it will allow us to do is this. So it'll eliminate a significant portion of what's involved in specifying, ordering, and delivering equipment for our projects. If we're ordering standard equipment, then we can minimize the amount of FATs that we need to do. We're reducing the amount of customization that we're going to do, and it minimizes the amount of drawing review that we need to do. If it's a standard solution, we don't need to review the drawings. And so we're eliminating quite a few of the steps. And so we're continuing to look at all of these activities. Kind of the drivers for my group is it an area where we continue to have problems? If that's the case, then we need to solve it. Is it an area where we're spending a significant amount of time, an excess amount of time? Then we need to come up with better ways to deliver that for our projects. And so that's what we're doing. So right now we're driving improvements and change to keep IC&E off critical path. We're encouraging new ways of thinking about technology to drive innovation. We're standardizing on processes and technologies to ensure consistent project application. We're institutionalizing these techniques within the industry. I'm here speaking today. We're meeting with our EPCs one-on-one to discuss all of these concepts, hopefully get their buy-in to what we're trying to achieve. And we'd like for this to become the approach that we all take. We benefit significantly from that. We've been sharing these ideas broadly because if we get others to do it, then there's more market share for the suppliers to progress technologies. There are technologies that we need developed. If there's a greater market share, then they'll be interested and encouraged to develop them at a rapid pace. And so we're also interested in these becoming core solutions such that they'll be sustained. And we're also interested in continuous improvement, not only from us, but from our competitors. So we're sharing this broadly. Internally, we're communicating this within all parts of our organization. We're getting everybody on board. It's not enough just to talk to the project teams. We're talking to our procurement organization. We're talking to the folks that develop all the contracts for our projects and develop the strategies for our projects. So anytime we find one group saying, well, I'm used to doing it this way, we need to do it, that's what I'm familiar with, that's what we're going to do, then I send out notes to all the other parts of the organization where I've already gotten their buy-in, and then they then will get on top of the group that's being a little cautious about progressing this forward. The other thing that we're doing is that we're implementing all of this stuff as a package, as a group, because what we believe is that if we did this in kind of an incremental way, one by one, justifying it on a one-by-one basis, we may get some improvement slowly, but I'm afraid the momentum to do it the way we've always done it will just continue, and we'll revert back to the old ways of doing things. So we're dumping all of this stuff on at one time, because when you add up all of the savings and benefits from doing all these things, we think we reduce engineering by 30% or more. We're reducing component count by 50% or more. We're reducing the amount of construction work significantly, the amount of commissioning activity significantly. And so when you throw all that out for the complete package, it's a little difficult to argue against it. And then we're sharing this broadly. So we attend conferences like this to discuss these ideas. We're talking with all of our key suppliers. We have an event annually where we bring all of them in to talk about the challenges that we're trying to solve and what we're interested in doing. And we're getting ready to have our second one in the next month or so. And then we're sharing it in a number of events. So IEEE, we've got 2 of the keynote speeches for the next IEEE meeting. We'll be discussing some of these ideas. So we're going to continue doing that. So that's it.